All right, so we have this problem. Find the exact value of sine of the quantity cosine inverse of minus 4/9 plus cotangent inverse 5/7. Again, let me begin by underlining these two quantities here, and these two quantities are actually angles. So I'm going to call A to be the cosine inverse of minus 4/9 and B to be the cotangent inverse of 5/7. All right, yeah, so whenever you're taking the inverse, cosine, sine, tangent, cotangent, whatever, inverse trig function of a value, as long as it's defined, it's an angle. And one thing that I want to point out that I think is really important with these problems when they're pointing out a cosine inverse or whatever, sine inverse and inverse trig function, is that you state where the angle here, the range for the angle is at. Cosine inverse gives you an angle between 0 and pi inclusive of the endpoints, and cotangent inverse gives you an angle that's also between 0 and pi, but not inclusive of 0 and pi. So you don't include 0 and pi. Okay, and yeah, I always tell people to do that. Just take a second before you actually, because what a lot of the time you'll go ahead and see people write these out and then they'll try to get to the computations, but I like to just say, let's go ahead and just look at the angles that you're looking at, and then from there, because typically you're gonna have to find the sine, the cosine, some other trig function of the angle that you're working with, and you're gonna be stuck if you don't ask yourself where the quadrant is for that angle, because it makes a big deal, right? You might be off by a positive or negative. Okay, now furthermore, let me start with A equals cosine inverse 9. This is like saying cosine of A equals minus 4/9. And this is saying cotangent of B equals minus 5/7. And in particular, A here has to be in quadrant 2. Because if the cosine of the angle is negative, and if your angle range is between 0 and pi, between the first and the second quadrant, then it's got to be in the second, because that's where cosine is negative. And with that same reasoning, I'm going to say that B is in quadrant 1. Okay, oops, I'm sorry, I put a negative there, I apologize. So yeah, lesson here, make sure you get your signs correct before moving on. So yeah, B would be in quadrant 1 because cotangent is positive in quadrant 1 and it's negative in quadrant 2. All right, so when I look at this original expression, let me go ahead and copy and paste this. Here, I'm going to rewrite this as the sine of A plus B. All right, this is A and that's B. And what do we have? Well, we have the sum identity for sine. And that identity says that the sine of A plus B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Okay. And essentially what you have to do is you kind of just have to fill in the blanks for the sine A, cosine B, cosine A, sine B. And we already have a value already. We have, let's go ahead and highlight up here, cosine of A is minus 4/9. So you can actually just plug that in directly right here. But I don't have the rest of the values here, which we need to get. So I need to find sine A and the values for cosine B, sine B. So let's start with A here. So we know that A is in quadrant 2, and we were told earlier that the cosine of A was minus 4/9. So here's A, and here's where our angle would be. Well, cosine is like saying x over r, so this would be minus 4. This would be 9 here. So if I'm looking for sine of A, that would be y over r. So the sine of A would be what? Well, I don't have what y is, so I need to find that, and I can use the Pythagorean theorem. So that would be the square root of 65. So I'll let you do that, okay? So sine of A equals minus 4/9. I'm sorry, y over r root 65 over 9. So we're just going to put that in there. All right, now for the values of B. So now we're told B is in the first quadrant. Or sorry, not told, we derived that. And as I said, the cotangent of B is 5/7. And cotangent is x over y. So this is x, this would have to be y. And if I want to know what sine and cosine are, because that's what we need to do, again, we need to find the sine of B and the cosine of B up here. Well, yeah, I need to find r, and r in this case would equal, let's see, here, 7 squared is 49, 5 squared is 25. So r squared would be 74. So the square root of 74 is what we would have. And yeah, for the cosine of B, that would be 5 over the square root of 74 because it's x over r. And then for the sine of B, it would be 7 over the square root of 74. And we'll just put that in here. So 5 over the square root of 74 plus, and then sine of B is 7 over the square root of 74. And we will go ahead and multiply all that out. Okay, so I'm going to go ahead and, let's see, can I move this stuff down a bit? Yes, I can. There's some more room here. And you would get 5 times the square root of 65 over 9 root 74 minus 28 over 9 root 74. So 5 root 65 minus 28 over 9 root 74 would be your answer. Not nice, but it is what it is. Okay. All right. Hope this helps. Thanks for your time.